Ledger. So everyone's muted, everyone's cameras are off. That's great. We're just trying to do that to minimize bandwidth usage and make sure that everyone can hear me without interruption. Hopefully you guys have followed the setup instructions for today. The first lesson will kind of be going through the setup that hopefully you did before the lesson, but you should have basically set up an RStudio Cloud account, which is here. You should have copied this project into your own account and made it a permanent copy. Essentially, this RStudio Cloud version will have all of the libraries, all of the R packages we're using for today, as well as all of the data sets. So you can use this as your one-stop shop for all of the resources today that we're going to go over. The other option for setup was, of course, to install RStudio on your own computer, not using RStudio through a web browser. So you'll see me doing that today. I have my own version here. I'll be going back and forth between RStudio on my own computer and the website as I go through the material. But essentially, I think the best setup for you guys as attendees today, if you're using RStudio Cloud, that should be open and viewable to you. Also, make sure you have the website open. So I'm just going to be going through the content on the website today, just going through the exercises, narrating what the text says, and going through the examples. So have RStudio Cloud open, have the website open with the training content. If you're not using RStudio Cloud, again, you can use your own installation of RStudio. And then finally, the last piece of information is this live coding link, which is a link that should be available in the welcome message you got in the chat in GoToMeeting, but it's also on the website as well. Right here, you can get to that link there. So essentially, this live coding link is going to be useful for you if you get lost or you want to see where we're at in each lesson. So as I type in something, so I'll say 1 + 1 and save that. And if you go to the live coding link and refresh your page, you'll see that there. In theory, there it is. So it's been updated. So I just added 1 + 1. So you'll have to refresh it every time to get the new content. And of course, I'll have to be vigilant in saving the script as I go, which I will hopefully be doing. So again, 3 things you can have open: RStudio, the website, and the live coding link. So that should keep you focused on what we're doing for the day. I strongly encourage you, if you have 2 monitors, to use them, because it can be tricky to flip back and forth between the different tabs. So make use of that. That's definitely what I'm doing as I'm going through the workshop. Yes, I covered that. Also, I guess one last piece of information about each lesson. You'll see on the website that there's an R script associated with each lesson. If you prefer to use that, you can just download that and open that directly in RStudio. So I have that one on my desktop that I just downloaded. I'll open that, and this is all of the R script that I'll be going through in each lesson. So you can just use that if you just want to send code from the script to the R console instead of typing it on your own. I just sort of provide that as a way for you guys to keep up without trying to track everything if you prefer to do that. And if you did follow the setup instructions, you should have installed all of the required packages and downloaded the data sets. And again, if you're using RStudio Cloud, you didn't have to do that, because that should have been pre-installed with the project you copied, so don't worry about that. So let's get rolling. I'm going to start the R Basics lesson, and when this lesson is over, we'll stop recording, and I'm going to start a timer, which you'll see here, so you know in between the breaks how much time you have before the next lesson starts. So I'll try to put that on the screen in between each lesson and during lunch as well. So let's get rolling. Also shout out to our moderators. If you do have questions, feel free to enter them into the chat. We have several people online that can help you with various R-related questions or questions about the workshop. So don't be shy in using the chat as a resource for figuring out what's going on if you're lost. Okay. So now we're going to get into our basics. When I sent out the poll for the registration, one of the questions was, please rank your level of experience with R. And a vast majority of people that responded said they were basically at a 1 or 2, meaning they had no or very little experience. So in the spirit of not alienating these people, I wanted to start from ground zero with R. So I know a lot of you are just at that point, and I want to make sure that you have a solid foundation moving forward with your R journey. Please be aware that this entire workshop is going to be a fire hose of information. You're going to be overwhelmed. You're probably going to get lost at times, and just realize that's totally okay. That's totally normal. Everyone has that experience. The goal of today is basically just to get you familiar with what's possible and to use this website as a resource moving forward, because I guarantee you, if you sit through all of the lessons today and in the future, you hear something about R that you're like, oh yeah, that sounded familiar. I heard about that in the workshop. You can go back to this website and say, okay, here's some more detailed information that I can go through because I remember hearing about this in the workshop. So don't expect to hear everything today and retain all of the information, because it is going to be a lot that we're going to go through. So just keep that in mind. So everyone's here today because they want to learn about R. So I'm just going to assume that we're all sufficiently motivated to want to learn this. We probably heard from a colleague that it was a great resource, and we want to learn how to use it for our own activities at our own work. So you probably have a sense for what R is. It is, of course, a programming language that was built around statistical computing. So that's kind of what sets it apart from other programming languages. It was developed specifically for statistical analysis, but it can, of course, do much, much more than just stats. It's a very valuable tool that I hope through the course of the day you'll realize that it is a proper bona fide data science programming language. So with this intro lesson, I'm going to cover a few things, and at the end of this, you should have some answers or know where to find answers to these questions here. So what is R? Why should I use it? What is RStudio and RStudio projects as a differentiation from R? How can I write, save, and run scripts for coding in RStudio? Where do I find help? What are the basic data structures in R? And how do I import data? So I usually like to make this pitch in the beginning about why you should invest your time in R. There are a lot of programming languages out there, but as I just mentioned, R is in essence a statistical programming language, so that in itself has a lot going for it. But like I said in the beginning, I've been using R for 12 years, and I've been seeing the growth and popularity of this program really blossom over the last 12 years. So if you, in your own time, if you're going through this content, you can click on these blogs and see how R ranks according to other programming languages. So it's actually grown a lot in popularity, and a lot of that has to do with the tidyverse as one aspect of it, which we'll get into in the next lessons. But a lot of it also has to do with the fact that it's free and open source, so anybody can download it. There's a lot of resources available to you. And actually, as of yesterday, there are over 15,000 supplemental packages that others have written for R and contributed to this software that you, as a new user of R, can download on your own and make use of them in your own time. So if you're going to be using R, I strongly encourage you to use RStudio. RStudio has not been around as long as R, but it is a great resource for really enhancing your R experience. So it's called an interactive development environment, an IDE, which is basically a way to, again, make your R experience a lot more enjoyable and simpler. So think about R as like the engine of a car, and RStudio is the rest of the car. So RStudio is the air conditioning or the seat belt or the safety features, basically things to make your whole user experience a lot more simpler. So it's got a lot of great things such as version control, debugging options, dynamic documents, packager manager, code highlighting, and so on. So moving forward, we're just gonna get familiar with RStudio and how you want to use it. So I'm gonna open this up on my end. These next couple of sections are basically going through RStudio, so just watch for now. This is my version of RStudio I have installed on my computer. And so you'll see there's a couple different panels here. So there's 4 here you need to focus on. And if you're using RStudio Cloud, it should look very similar. There's no scripts open in RStudio Cloud, but if you want to open R Basics, we can do that. So it's right there. So the 4 panels are the source panel on the top left, the console panel on the bottom left, this set of tabs on the top right, that is your environment, and I'll explain what that is, your code history, any database connections, a build tab if you're building websites with R, and integration with Git, which is a version control, which we won't get into today. On the bottom right here, we have another set of tabs, which is a file pane, which is kind of like your file explorer, a plots tab for viewing plots, your package manager, any place you, if you want to load help files, they'll pop up here on the help tab, and then a viewer, which is a way to view interactive things or plots that you might make, which we'll do at the end of the day. So these are your 4 basic panels. When you are using RStudio, you'll be spending most of your time in the source panel on the top left. So writing code, text, which are commands that you'll send to the console down here, which is actually R, that executes those commands. And so we'll run through that process in the next few minutes of writing script and sending it to the R console. So that's a little overview about what the different panels are. An RStudio project is a way to kind of modularize your workflow when you're using RStudio. So I strongly encourage you to use RStudio projects when you're working with R. This is kind of like a central location. Got some audio there. All right, so I think we took care of that. So RStudio projects are a centralized way to take care of your code, your data, and anything else you're working in your typical workflow. So if you're in RStudio Cloud, this is already a project, so you don't have to worry about this. But if you are using RStudio on your own, to make a new project, you go up to the File menu, New Project, click New Directory, New Project, and then I'm going to put it on my desktop for now. And so you can do this on your own. And I'm going to call it R Workshop 2020. You call it whatever you want. Create that project. And then we basically open up a new instance of RStudio that there's nothing in it except for an R project file and the R console. So again, just kind of get comfortable using RStudio projects because this is your centralized location of working with data and scripts. What it is really it's just a directory at this point. So if I put mine on my desktop, you can see it right there. Here's the directory where it is. Right now, there's nothing in it. There's just an R project file. So Windows knows and RStudio knows this is an RStudio project. And then there's an invisible file that is just some sort of meta information about the RStudio project. So I'm going to populate this project with data and scripts, which is something you've hopefully done in the setup, but just to walk you through that, show you how that's done. So go back to my project. I'm going to open a script, go up to New File, in the File menu, our script, and now we have a script. And so it's untitled, it's not saved, but it opened up in the top left in the source pane of RStudio. I'm going to save it in my project as my first R script, or whatever you want to name it. It's just a file name. Save that, and notice we see the script now here in our file pane. So the project knows this is where all of our files live. And then we're going to put some comments on the top of my first R script. Save that. So now we have a script. And again, this is where you're going to be writing your code, whatever you want. And in a second, we'll send that information to the R console to actually execute that code. So what I'll do now, so that's just sort of running through a project and making an R script. It's usually a good example or a good practice to write all of your code in an R script and just send it to the console when you're working. Generally, you would not want to write code directly in the console, which you can, but you want to have a record. That script is a record of your workflow. So I would strongly encourage you to use scripts and have that as a saved file that you can use and load when you're not using, or in between R sessions, essentially. So what I'm going to do in the spirit of using live coding, I'm going to open up the live coding script into this project that I've made, so you guys can see what I'm doing. So now I have my live coding script, and I'm going to write the same code that I just wrote and some other stuff. Save it so you guys can have it. Now, to send code from your script to the R console, you basically, there's a couple ways to do it, but you see where my mouse is. I can basically put the mouse on the line where that line of code is and hit this button up here, this run button. This says send the code to the console and run it. So if I run 1 + 1, I get 2, and I see some output on the console down here. So this little symbol, I don't know what the name of that symbol is, but this is basically saying this is the code I'm going to run, and this is the output. So we see 1 + 1 is equal to 2, and then this guy right here is basically just an index that says this is one item that I've returned. So this is the first item that I've returned. If I run this command, print hello world, this is just saying print this text, hello world, and then in the console, this is what's returned. So you can run it with the run button, and you can see when it's run, it sends it to the console, and then the line in your code, in your script actually, goes down to the next line. So that's one way to send code. You could also send blocks of code if you highlight everything. So I can send 1 + 1 and then print at the same time. Or there's a keyboard shortcut, which is what I use in RStudio. If you use Control-Enter, you can send it as well. So there, I've done it. You can't see me doing this on the keyboard, but you can assume that I'm doing it. So if you're in Windows, it's Control-Enter. If you're using a Mac, I believe it's Command-Enter. But that does the same thing as hitting the run button. So every time you run code, you can do that as well. And I find that easier using the keyboard shortcut so I don't have to go up to the run button every time with the mouse to run it. If you do source, you can basically run an entire R script. So I believe you don't even need to highlight everything, but if you do source, basically I've just run the whole thing now. So if you have a script that runs a whole bunch of processes, you can source that whole thing by hitting the source button. So that's how you run code. Pretty straightforward. All right, so we're going to do our first exercise now. This is essentially to get you familiar, give you a few minutes to run through RStudio, everything I just talked about, kind of just running through the example I just went through. So you're going to make your own project, create a new script, write a comment on the top. I failed to mention anything that is preceded by a pound sign in your script is a comment, which means R won't run it. It'll just treat it as something, yeah, it's not even, yeah, so it just, let me just copy that down there. So it doesn't do anything when something is preceded by a pound sign. So you can use these as comments to let yourself know what you're doing in your script. So it's always good to comment your code. So here I'm saying, here's something that prints text, just so I know what it's doing. And when I run this, it just does the part that I want to do, the printing of the text. So apologies, I forgot to mention that earlier. So I'll shut up now. I'll let you do the first exercise, basically setting up an RStudio project. In this last step, you're going to download the data and put it in your RStudio project if you haven't done that already. So I'm going to start the timer, give you 5 minutes. Off we go. Just a quick reminder, if you're using RStudio Cloud, you can skip essentially all of these steps, 1 through 5. This is just for folks that have installed it on their own. Okay, that's 5 minutes for that exercise. Hopefully you guys had a chance to walk through setting up a project. Again, if you're in RStudio Cloud, you didn't have to set up a project. Apologies, I probably should have mentioned that more clearly. But you can still set up a script that says, this is my R script, this is my first exercise, but then the data you should already have in the RStudio project in this data folder right here. So I'm gonna just quickly show you. So I've set up my RStudio project on my end, on my desktop. So this is my project I set up right before the exercise. I have my script here that I made here, but again, I'm using the live coding script to benefit you guys. But if I want to get data into that folder, essentially I would, so I got to download the data first. So I'm going to go back here, download the data from this link, go to my desktop where it is, and extract it because it is a zipped file. So extracting it to my desktop. And then what I need to do is, remember when you created your RStudio project, you specified a location on your computer when you made that project. And so I showed this to you guys before the exercise. So here's that folder where I have my RStudio project. You see inside of it, there's the RStudio project file, my script I made, and some invisible folders you don't need to worry about. To put the data in there, basically I would just go, whoop, copy that in there. Look, there's my data. It's in a separate subfolder in there. And now I see it in my project here as the data folder. So it's just like any file you would copy into a folder on Windows or Mac. You just copy and paste that in there. Now, when we start importing the data, I'll get into this in a bit, but if it's in this subfolder, you have to specify that location when you import the data, which I'll talk about. If it's not in that subfolder, it could be in the home directory as well. So it doesn't matter where it is in the project as long as it's in the project, in a subfolder or not. And again, if you're using RStudio Cloud, you should have the data folder already in there. There's a lot of content in here. This is actually the website here, all of the website files, but if you navigate to the data folder, you'll see that that's already in there. So you don't have to worry about that. All right. So that's the first lesson. I want to just talk a little bit more about R language fundamentals. So you saw earlier I used the print function. So R is built around functions. All functions are a set of other commands that someone has rolled up and put into a function that you could use and give it input to execute that function. So every function has this same makeup where there's the name of the function, there's parentheses, and then there's arguments that go inside of the function that basically say how whatever the function does is going to use input data or different options for applying the function. So here's print hello world. I'm going to show you some other ones just for an example here. So sequence 1 through 10, send that to the console. This creates a sequence of numbers from 1 through 10. Here's a mean value of, let's see, oh, I don't want to do that one yet. What are my examples? Okay, so this rnorm function, this is a good one. This creates a set of random numbers from a normal distribution. So this is the name of the function. This first argument says give me 100 random numbers from the normal distribution, where these additional arguments, mean says the mean of that normal distribution is 10, and SD is the standard deviation. So if I execute that, we see we get 100 numbers in the console here. And again, if you've never seen this before, this can be a little confusing, but these numbers here are basically indices that tell you what order each output is in the set of 100 numbers. So this one says this is the first number, 11, this is the 11th number, 21, this is the 21st number, and so on. So for most purposes, you can ignore these on the left, but if you haven't seen that before, it can be a little confusing. So that's another function. I could take the mean of that. So I can put another function around this function. So here I'm taking, here's 100 random numbers. I can take the mean of that, and I get something very close to 0, because the default behavior for this function is to take something from a normal distribution that has mean of 0 and standard deviation of 1, so your standard normal distribution. So if I do that over and over, I get random numbers each time, so the means kind of change. But you see it's set at around 0, as we would expect for a normal distribution. So back to our lesson. Now, a really important part of using R is saving things as objects in your workspace. So you'll see in this example here, this next one, I am doing something a little different. I'm taking a sum of random normal values. In this case, this is a sum, not the mean, but I'm assigning these values to something called my random sum. This is a name that I've made up. I could call it my sum, whatever you want, but essentially the output from this set of commands, this set of functions, I can save it to my sum. So what I've did is I've just sent that to the R console down here. Nothing happens because I'm not just running the functions as for the example above it, but I'm saving the output from the sum of these values to this object called my sum. So that's my sum. And if I type my sum into the console, or I could even put it up here and send it to the console, I see what that value is. So this is a way to save information in R that is used all the time. So you have a set of functions, you assign it to something, some name that you make up that should probably be semi-descriptive of what it does or what it's doing, and then you assign it to that object with this guy here. So I don't think there's a name for what this is called, but it's literally just the less than and then dash sign. In the old days, when R was first developed, this is a bit of history, but it was developed by Bell Labs, and it was developed it was actually developed internally within their company. And they had some company-specific keyboards that actually had this symbol on it. So there used to be in the old days a button for that, but now you actually have to type it out. There's actually a keyboard shortcut in RStudio to do that. So if you do Alt dash, you can actually get that without having to do Shift less than and then dash. So Alt dash is the keyboard shortcut for that. Let's see, I think if you go to keyboard shortcuts help up in the tools menu, you can see a very long list of all the keyboard shortcuts for RStudio. But again, the important part is just to know that this sign assigns output from functions to something that you name. So this R norm is, if I run that every time by itself, I get a new set of values. Because each time it's executing the function, it's taking new random values each time. If I assign it to something once and I routinely call my sum over and over, it doesn't give me new random numbers because I've saved that to that object, and it doesn't repeat it every time I call that up again by its name. So that's just a little distinction that's important to realize. When something is saved to an object here, it doesn't get executed every time you call it, unless you create it again. Oops. So here I'm going to recreate this object, my sum, and see I should get, I get a new set of values. So that's just because I've recreated again. But if I type in my sum, I get that same set of values again. What's also interesting is if you look up here in the environment, I have this thing called values in my sum here. So the environment is an important thing to understand about RStudio. And I have a bit of text here, actually R in general. The environment is a set of objects you have saved in your current R session. So again, I've saved this MySum object by assigning the output of these functions with this operator here, and it shows up here. So this is just a collection of things that I've saved in my script that I can go to and look at and say, oh, I saved something called MySum. This is what it is. So just realize that this is a good reference point to look at to see kind of what you've been saving in your current R session. You can always clean it up by hitting this broom button, but of course that gets rid of everything. So now my sum is no longer there. But if I create it again, I see, oh, there it's back. Okay, so just be aware that this is a tool or a tab in RStudio that could be helpful if you want to sort of keep track of what you're doing over time. All right, so I'm quickly running out of time for this first lesson, so I just want to briefly run through a few items. I talked about in the beginning how one of the popularities of R is the fact that it's open source, everyone can use it, and as a result, people have basically developed a large number of packages that then are essentially a collection of functions that anybody can download and use on their own. As of yesterday, there's almost 16,000 supplementary packages available, and where they go is this place called CRAN. CRAN is the Comprehensive R Archive Network. This is a place where R lives, as well as all of the packages. It basically lives on the internet, in different places around the world, but when you want to get packages, you would go to CRAN to download them. So to get a package, you have to install it first before you use the functions that are in them. So in this next exercise, I'm going to have you install packages onto your own computer and then load them so you can then use all of the functions that are available in those packages. Again, if you're using RStudio Cloud, those packages are already installed, but for your own knowledge, if you're not using RStudio Cloud, you can always install them on your own, as will the people do that are using their own version of RStudio. So take a few minutes to run through this exercise, install these packages, and then load them with the library function. So I'm going to start the timer, give you 5 minutes to do that, and I will be quiet. Okay, that's 5 minutes. Hopefully you guys were able to go through that exercise, get those packages up and running. One point of clarification, when you install packages in R, you only need to do that once, but every time you use R Studio, you need to load the package with the library function to use the functions in that package. So I already have these packages installed on my computer, so I'm just going to do library tidyverse, library sf, and then library map view. Then I'm going to send those to the console, and then you see some messages. That's okay. For the most part, you can ignore this information, but as long as you don't see any errors, you're good to go. And again, the rest of the workshop today we'll be talking about exactly what each one of these packages offers, specifically the tidyverse. So we have about 10 minutes left. I am going to quickly mention how to get help in R if you're lost. You can always, if you don't know what a function does, you can always just use the question mark in the console and then the name of the function, hit enter, and then you see a help file pop up. That can be very useful if you want to know what arguments it takes or how to run some examples with that function. But by and large, there's a ton of information available online that can get you started with R in addition to this website and this training. So Google is your best friend. I often like to joke that I wouldn't know anything about R if I didn't have Google. I Google all the time, every day. So just be aware that that is a great resource. There's a lot of communities online that you can use to understand or troubleshoot some questions you might have about R. And then down here, I have some resources you can use for continued learning on your own. Just a quick shout out to R for Cats. Totally awesome. If you like cats and you want to program at the same time, this is definitely for you. So cat specific examples, everyone loves that. I like that one. So yeah, finding help, just try to read that section on your own. It's kind of a once you navigate the resources that are out there, you can kind of get a sense for what works best for you in terms of finding help for R. I want to mention data structures in R real quick. All of these guys right here. So these are what's called vectors. So here I'm making a vector, which is a collection of objects. So a collection of numbers, a collection of integers, a collection of true-false statements, a collection of characters. I've assigned them all things that I've called various names for the purpose of describing them. I can send them to the console, recall them as such, and that's great. So to create a vector, you have to use this C function called concatenate. This is basically just a way to say I'm going to combine things into a single vector. So you have numbers, integers, true, false, and then character strings. So that's all well and good. We can actually combine vectors into a data frame like so, which is not correct the way I've done that. So there's that. So data frame is a collection of multiple vectors in two-dimensional space. So there's columns and there's rows. You can think about that as kind of like your typical spreadsheet setup in Excel. It's just a table of data, but each vector contains information, and each vector here has to be of the same type. So here's numbers, here's integers, and here's characters. and each row corresponds to an observation across the vectors. So the reason I'm showing you this is to not only get familiar with how to make a vector and how to combine them into a data frame, but when you're working in R, it's really important to understand that you're not going to be entering data on your own, usually. So you're going to be importing data to work with when you're doing your analyses. So this means you're going to tell R to pull in a spreadsheet or a table or a shape file from another source outside of R that you want to start working with. And so the data sets that I had you download are essentially data sets that we're going to import into R using this function, read CSV. So this last exercise is going to get you set up doing that. But before I get into some of the details about importing data, I just want to briefly mention a little bit about this concept called the working directory. So in order to import data into R, R has to know where that information is. If we're in a project right now, which you should be, your working directory is the location where that project lives. It's that folder we created when we created the project. We can see it up here, and then the default file location where that is on the right. And we can see that using getwd. So this says get my current working directory. I can see where that lives. C, users, Marcus, desktop, R, workshop 2020. Now the reason this is important is because when you tell R to import a file, it's going to look first in your working directory. So I have my data in a file or in a folder called data within my working directory. So if I want to import the data set, I would say, this is what you're gonna do in the last exercise for this lesson. I would write a relative file path for that because R knows that I'm in this current working directory with getwd, and this file lives in the data folder within this working directory. So if I run that, it knows to look in there. So I just imported that file, fishstat. That's great. We'll be very familiar with this by the end of the workshop. But that's just important to know that R is always looking from a location that is your working directory. Now, if you're in a project, it's set automatically to the location of that file or that folder where you created the working directory. But if you want to create a new working directory, you can use the setwd function. You shouldn't have to do this if you're in a project, but just so you know, there's the setwd function where if I want to say, just put it somewhere else, I can do that through that function as well. So just be aware of that there's this concept called the working directory and everything's relative to it. So in the last 5 minutes, we're out of time, but I'm going to let you play around with importing this data set from your working directory using the read CSV function. Now you have to load the tidyverse to do this because this read CSV function is part of the tidyverse. And we did that in the last exercise. So I'm going to give you a few minutes to do that, and then we'll wrap up this lesson. We got 5 minutes on the clock now. Okay, so we are technically in the break now, so I want to respect that time. What I'll do is I will write this code that works for this exercise in the live coding script, and you can copy that into your current R session, and you should be able to have all of the libraries loaded for today and importing some of the data sets that we're using. If you're having trouble, of course, you can try to reach out to us in the chat. But essentially, this lesson is a whirlwind tour of everything that is R fundamentals. So it's a lot to go over, and I realize it was a lot compressed into a short time frame, but you should have a sense for how to at least execute code and use libraries and functions. So we will start the next lesson in 10 minutes at 10:15 to start that on time.